Hey everybody, and welcome to McCardle Math Academy. In this video we're going to be doing a basic example of integration by trig substitution. So the example we'll be looking at is the integral of 4 divided by the square root of 9 minus x squared. So now because this integral has the form a squared minus x squared in the denominator, we know that warrants a sign substitution. So when we set up our triangle, we're going to be following the protocol for that particular substitution. So we're going to set the triangle up in the following way, where the base is the square root of 9 minus x squared. And we know that by the Pythagorean theorem, this makes the hypotenuse 3 and the height of the triangle x. Alright, and we have our angle theta here at the bottom of the triangle. Now from the triangle, we're going to dissect some important information. And because it's a sine transformation, we're going to start with sine of theta. And by basic trig rules, we know that that's opposite over hypotenuse, so we get x over 3. And we solve that basic equation for x to get 3 sine theta. We're then going to take that and take a derivative with respect to theta to find what dx is. So you find that dx is 3 cosine theta d theta. Alright, let's box that. So in this black box is all the important information that we're going to use to make our substitution. And the goal is to take this integral here and to have everything be in terms of theta instead of x. So you notice that we're going to need to replace the square root of 9 minus x squared as well as dx. So what we're going to do before we come back to the integral is we're going to use the triangle in a unique way, and we're going to solve for the square root of 9 minus x squared. So that's this base of the triangle. And if you notice, if I take cosine of theta, you're going to get the adjacent side, which is the square root of 9 minus x squared, that's what we want, divided by the hypotenuse, which is 3. And just solving that with some simple algebra, we find that the square root of 9 minus x squared is 3 cosine theta. Alright, and we're going to use this when we come back to our integral. So let's come back to the beginning here, and we make our substitution according to the information we just found. So we now have 4 divided by, and again we're going to replace the square root of 9 minus x squared by 3 cosine theta, because we just found that to be 3 cosine theta. And we replace dx by what we found it to be, which is 3 cosine theta d theta. Alright, and at this point you should be pretty excited because everything cancels out, and we're just left with the integral of 4 d theta. Alright, that's a very simple integral. It's all with respect to theta, so you end up with 4 theta plus c. And you're almost out of the water. We now just have to bring this back to be in terms of x. Alright, and to do that, we come on back to our triangle and we solve for theta. So let me grab another color here. We take this equation here, sine theta is x over 3. Apply arc sine to both sides, and you'll find that theta is arc sine of x over 3. Now whenever you introduce these inverse trig functions, know in the back of your mind that you have to actually restrict the domain of theta, but for indefinite integrals it doesn't actually affect the outcome. For definite integrals it would. So we come back over here and replace theta with what we found, so we have 4 times arc sine of x over 3 plus our integration constant c. Alright, and that would be your final answer. So let me zoom out here so we can get a broad look at what we just did. We took our integral. We noticed that it had the form a squared minus x squared, so we set up the triangle according to a sine transformation. So let me circle this. This triangle is the protocol for a sine transformation because these transformations work for the form a squared minus x squared. We then used our triangle, after we set it up, to find each little piece that we would need to make our substitution. In doing so, we converted the entire integral to just theta, and then we found a basic integral with respect to theta, and finally went back to x. Alright, I'll see you guys next time. Hopefully this helps.